Hello, ladies and gents of the sophomore class taking chemistry. This is the Moles Chem quiz review practice thing that me and Mr. Ballard gave to you guys. So I downloaded a digital copy of this, and it had solutions as its heading, so I crossed it off and put moles and stuff, by the way. Also, as a heads up, I forgot my Apple Pen at school, so I'm using a different stylus. You might have to forgive my atrocious handwriting throughout this video. I might even go into angry rants about it. Anyway, nevertheless, let's begin. Number 1, what is the mass of 1.5 moles of CO2? So, we are looking for moles. I mean the mass of this 1.5 moles. We need to look at our equation here from the reference table where it says number of moles. So this equation is from the reference table T, where the number of moles is equal to the mass, the given mass over the gram formula mass. I'm writing GFM to approximate it. And this is also the same as molar mass. So in most questions, they're going to give you the molar mass, but in case they don't give it to you like this problem, we have to calculate it ourselves. And that should be simple for CO2, given we're using elements that are frequently used. So let's figure out what is our molar mass. So we have 1 carbon and 2 oxygens. So 2 times our molar mass of oxygen, atomic mass is 16. And for carbon, that's 12. Okay, 12, 32. Add them up and you get 44 grams per mole. Keep in mind, 44 grams per mole. If we have 1.5 moles, we should have a number that's bigger than 44. Okay, and that leaves us with choice 1, 66 grams. If you actually calculate for it, so 1.5 equals x over 44, you'll do 1.5 times 44, and you'll get 66 grams. If you think about it logically, if you know there are 44 grams in 1 mole, and we have more than 1 mole, it should be more than 44 grams. Okay? Number 2. Formula mass of a compound, this is the same as molar mass, is the sum, so we could cross off 1 and 4, of the atomic masses, not the atomic numbers. Sum of the atomic masses of its atoms. Number 3. A sample of a compound contains 65.4 grams of zinc, 12 grams of carbon, and 48 grams of oxygen. What is the mole ratio of zinc to carbon to oxygen in this compound? So what it wants you to really do for this question is to look up the atomic masses and figure out how many moles are in each sample of each element. So for zinc, you have 65.4 grams, and in each atom of zinc is also 65.4 grams, so this comes out to 1. For carbon, it's 12 grams over 12 grams because there are 12 grams in 1 carbon. Now for oxygen, we're following the number of moles equals moles over GFM equation up at the top. So you're given 48 grams. And if you look at the reference table, there's 16 grams for every atom of oxygen. 48 divided by 16 gives you 3. So we're looking for an answer choice that has 1, 1, 3, and that's choice 4. Alright, number 4, and then I realize here number 4's choices have been scrambled. So keep in mind my version of this paper has the same questions in the same order, but the choices might be scrambled, so go according to your version. I might be saying choice 4, but it might be choice something else for you. So keep that in mind. The choices are the same, they're just scrambled. Okay. Number 4, in which compound is the percent composition by mass of chlorine equal to 42%? So, what I highly suggest is look at each of these choices. We're looking at chlorine. The mass of each chlorine atom is 35.5 grams approximately, okay? 35.5 grams for every chlorine, and each of these 4 choices has only 1 chlorine. Okay, so that's the mass of your part. If you look at the equation, percent composition equals mass of the part over the mass of the whole, which is the gram formula mass, times 100. So you're taking each of the 4 choices, do 35.5 divided by the given molar mass, and find which of them comes out to 42%. Okay, so 35.5 divided by 52 is more than 50%. 35.5 divided by 100 is exactly 35.5%. 35.5 over 84 comes out to 42%, but if you check with 35.5 divided by 68, that's a little bit more than 50% as well. So that's not the choice either. Choice 3. You take each of the four choices, 35.5 divided by 84 times 100 will get you that 42% you need. So that's a strategy to go for it, to go through each of them like that. Okay. Now, number 5, what is the percent composition by mass of nitrogen in NH42CO3? And they give you the molar mass, so you don't have to go through that extra step. So what you're doing is figure out how many nitrogens are there, okay? So we're going to do part over whole times 100, okay? So we have 2 nitrogens. If you look here, it's inside the parentheses, and there's a 2 on the outside. So 2 of whatever's inside, so we have 2 nitrogens. Each nitrogen is 14, okay? So 2 times 14 is 28. 28 grams over our whole, which is 96 times 100. So keep in mind, the part you're looking for is nitrogen. There are 2 nitrogens, and each of them are 14. So you have 28 grams over your 96 grams total times 100, and that should come out to about 29.2% as your answer. Change the color now. Okay, number 6. Which sample contains a total of 9.0 times 10 to the 23rd atoms? So if you know that each mole carries this many, that means you have more than 1 mole. So 1 mole is 6.02 times 10 to the 23rd of atoms. So we need more than 1 mole. So choice 2 and 3 are out. Now, choice 1 and 4 have the correct number of moles. Okay, if you figure out how many moles this is, it's actually 1.5. Now we're thinking about atoms. Let's look at choice 1, 1.5 moles of H2. However, we have 2 atoms in every mole of H2. So we actually have more than actual 1.5 moles of atoms in choice 1. That's why choice 4 is correct, because there's only 1 atom in there versus choice 1, there are 2 atoms. So it's even double the amount. All right, if you're able to follow me there. Number 7, what is the total number of nitrogen atoms in 0.25 moles of NO2 gas? So let's see, let's use dimensional analysis here. So let's 0.25 moles. Okay. 6.02 times 10 to the 23rd mole atoms. Okay. So when you do 0.25 times 6.02 times 10 to the 23rd atoms, because now that's what the unit we have left, we get 1.5 times 10 to the 23rd atoms as our answer. And that's choice 1. Okay. So if you also think about it logically, 1 mole equals 6.02. So that means if we have a quarter of a mole, we should have quarter the amount. And that's 1.5 times 10 to the 23rd. Number 8. A compound has a gram formula mass of 56 grams per mole. What is the molecular formula for this compound? So the easiest way to go about this is to go through each of those choices and calculate for the gram formula mass. Easy enough is that the elements are carbon and hydrogen, so these numbers you should already be familiar with. Carbon is 12, hydrogen is 1. So let's look through each of these choices. So choice 1 happens to be the correct answer, comes out to 56 because it's 48 plus 8. Choice 2, you have 1 carbon, so that's 12, plus 2, that's 14. Choice 3 is 24, plus 4, that's 28. Choice 4, that's 36, plus 6, that's 42. If you want to go through that extra practice of calculating molar mass anyway. Now, number 9, I told my students to skip because we didn't talk about hydrates yet, but let's just practice with it anyway for those who are curious want to try it. So I'm going to do this one in red. Okay. A student obtained the following data to determine the percent by mass of water in a hydrate. So we had to calculate the amount of water in the hydrated salt in milligrams. Okay. So here, we're looking at these two things. So mass of the empty crucible plus the cover is 11.7 grams. And the 14.9 grams is the mass of the crucible and the cover and the hydrated salt before heating. Because when you heat it, you evaporate away the water and it becomes anhydrous. Okay, so we're looking at these two things. So if we subtract these two numbers, we get the hydrated salt by itself. And we get 3.2 grams. Now it wants it in milligrams. So to go from grams to milligrams, there are 1,000 milligrams in every gram. So I'm going to show you dimensional analysis to do this. Okay. So you just multiply by 1,000 and you get 3,200 milligrams for part A. Part B, we have to express this in scientific notation. So you could still get this question right even if your answer to part A is wrong, your error will be carried out. Oh, this is like physics. You could get the first question wrong, but you could get the credit for the rest of them if you know what you're doing, because your answers are carrying over. Okay. So you got to express this in scientific notation. You got to bring the decimal to the left 3 times over. And you get 3.2 times 10 to the third milligrams. Okay, that's your answer for part B. Letter C, well, we're not really, I didn't cover significant figures with you guys, so I'm going to skip this one. And part D, what is the percent by mass of the water in the hydrated salt? So this is something that's probably more relevant to us right now. And I'm going to do this one in blue. So what is the percent by mass of the water? So if you compare these two masses, one of them is basically the whole setup plus the hydrated salt, and the other mass is the whole setup with the anhydrous salt. So when you evaporated the water. So if we take the difference between these two masses, we could figure out how much water we evaporated away. Okay? So we should get 0.37 grams. 0.37 grams of water. What is the percent by mass of the water in the hydrated salt? Okay, so this is for our water. The one up here is for the hydrated salt. Okay. So mass of part over mass of whole. So I'm going to do this section over here. 0.37 grams over 3.2 grams times 100. You will get 11.56%. Okay. Number 10. So this can be tricky if you aren't reading carefully. So here, the intro is not really important right now, but look at this question right here. We need to show a numerical setup for calculating the percent by mass of NaCl in a solution in beaker 4. Okay, so we're looking at beaker 4 right here. We don't need the boiling point right now. We need to figure out what is the percent by mass of NaCl. So we need to just show a setup. So our part here is just the NaCl. Okay, and that is 35.04 grams. Now the solution, is not just the water. It's the combination of both the water and the NaCl. So you need to combine both of these numbers together. The common mistake is to put over 100, but our whole sample is 135.04 grams. So that's what we're going to do. Our setup is right here. Percent comp. You need to show this exactly to get the credit. 35.04 grams divided by 135.04 grams times 100. If you show the times 100, you get the full credit. If you leave out the times 100, you're not going to get the full credit. So make sure you include that times 100, because I know some of you can easily recognize the percent without multiplying it by 100, okay? So make sure you show that times 100 in that formula, following everything to the T. Number 11. Show a numerical setup for calculating the number of moles of SnO2 in the 3-gram sample. Okay, so we're looking for number of moles. We just need to do a setup. So number of moles equals given mass over the gram formula mass. Okay, so we're looking for number of moles equals, what's our given mass? 3. They gave us a 3-gram sample, but what is the gram formula mass? You can either calculate it yourself or read the problem, and it's right there. They gave it to us. 151 grams per mole. Don't forget units. Okay, and that's all you need to show, the setup. If they ask to calculate it, you do the math, but you don't need to do that. They just want a setup. Number 12. Let's do this in red. Determine the gram formula mass of 1,2-dibromobutane. What the hell is that? Well, they give it to you in the problem. Read carefully, guys. C4H8Br2. Okay, let me just... Okay, Br2. So, we have 4 carbons. We have 8 hydrogens. And then bromines, we have 2 of them, and each bromine is 80, if I recall correctly. So you multiply it out, and then you add them all. So 48, 8, and 160. Add them all up, and you should get 216 grams per mole. Do not forget that unit. Now look at this doozy whopper of a question. Look at this structure. What the hell is that? Well, we don't need to look at this stuff. And, well, we don't need to look at a lot of this information. It just wants us to show a numerical setup for calculating percent composition by mass of sulfur in this whole thing. What is the gram formula mass? Well, you don't need to read all of that. You just need to read the last sentence. Everything else here, you don't really need to look at that. Okay? That's all we need. Just a setup, guys. Percent comp equals mass of the part. So sulfur is, there are 32 grams for every sulfur, and there are 2 of them. So the total mass we have of sulfur is 64. So that's the mass of our part. Because if you look at the formula, there's one S inside the parentheses, but there's a 2 on the outside, so we got to multiply by 2. So our mass of the part is 64 grams over the mass of the whole, which is 474 grams, times 100, and that is our percent composition setup. That's it. Okay, number 14. In the space below, calculate the gram formula mass of glycine. We need to calculate it, and it has to include both the numerical setup and the calculated result. So that means you got to show your work for it. Okay. Glycine is right here. Everything else you could just ignore. Let's do this in purple. NH2, CH2, COOH. Let's break it down. There's 1 nitrogen. There's 14. Plus, we have 2, 4, 5 hydrogens. And then how many carbons do we have? We have 1, 2 carbons. And then we also have 2 oxygens. So that's our setup. That's part of the answer. Now we need to add them all up to get our answer. So 14 plus 5, that's 19. 19 plus 24, that is 43. 43 plus... Well, I got tired of doing this in my head, so I just went to my phone to calculate it. 75 grams per mole. And that's our answer. Number 15. Determine the mass of 5.2 moles of C6H12 given the GFM of 84.2 grams per mole. So we just need to calculate it. 5.2 moles Okay. So that's using dimensional analysis to do this. And our answer is 437.84 grams. Okay, so that's our answer. You could do this using the formula or dimensional analysis. And then number 16, given the compound C4H10O8, I'm going to do this on the other side in blue. Calculate the molar mass of the compound. All right, we have 4 carbons. Oops. Okay, we also have 10 hydrogens and then 8 oxygens. Calculate all that. You'll get a total of 186 grams per mole for part A. That's our answer. Part B, calculate the number of moles in 17.7 grams. Okay, 17.7 grams over 186 grams per mole. The number of moles will be definitely less than 1. Okay, so 17.7 divided by 186 will get you 0.095 moles. And that's for part B. Part C is looking for the empirical formula. I'll do this in green. Empirical formula, you're looking at this compound, so you just got to reduce it. So you could divide them all by the greatest common factor, and that's 2C2H5O4. Can we divide it even further? No. So that's it. And that is the end of this practice quiz with all the mole practice questions. You can look back on some of the gas law review videos that I did if you want to review some of those for the IA. And yeah, hope that was helpful, guys. Take care.